Welcome students to the series of lectures on hypothesis testing. And this is one of the most important discussion as per your curriculum because in statistics, if your institute, as in the CFA or FRM institutes, GARP and CFA wants to test you thoroughly in statistics and without going deep into the complex topic of uh, regression and time series, then the most effective way for them to test you in statistics is hypothesis testing. So from an examination point of view, this topic is very important, very critical. So please be very focused in this session because this session is for your examination. And if you understand hypothesis testing in and out, then you can score pretty well in your quantitative method, in your quantitative analysis, in your statistics section in the examination. Apart from that, I just want to mention that even in real life, from the real life perspective, this topic, hypothesis testing is super critical because I consider it as the culmination of statistics. You cannot be able to perform hypothesis testing correctly if you do not understand each and every component of statistics pretty well. This is reason number one. The second is it is a very powerful method. Hypothesis testing gives you a very powerful method, a set of rules through which you can test your belief. And that's why it is very important because see what I'm trying to say here is that in the coming years of your life, of your career, you will form certain beliefs about the financial market, beliefs about economics, belief about commodities, beliefs about economic policies, or belief about investment strategies. But the question is it that your belief is always true? Is it always correct? And because it's your belief, it is a correct one, the right one? The answer is if you're a true researcher, you should test your belief. Just because you believe something does not mean that is the truth. For example, someone once believed that Earth is flat, but that was not the truth. So, how do you discover, how do you find, how do you decipher whether what you believe is correct? Otherwise, we all tend to become self centered. We think what we believe is always correct. We think our belief is the purest belief on the planet, the truest belief on the planet. But if you're a true practitioner, a true financial analyst, a true researcher, then you need to test your belief. But how do you do systematically? How do you do perform that testing on your belief? At least thanks to statistics, because it gives you a method. It gives you a method to test your belief, that is hypothesis testing. So if you have a belief, you have to first ask the question, as a researcher, is it always true? If not, then how would you test it? Statistically, you can test it with the help of hypothesis testing. What the word hypothesis stands for? What the word hypothesis stands for? Hypothesis stands for belief. It simply means your belief. The hypothesis testing mean it's your belief, let's test it. That's it. So you're testing your belief. That is testing your hypothesis, testing your belief or testing your hypothesis. So in statistics, they're defining set of rules. They're defining certain steps. And if you follow these steps diligently, you can test your belief statistically, properly, correctly. And these steps becomes more refined. These steps becomes more refined as you gain more experience in hypothesis testing. Because this is slightly complex, but I'm just giving you the reason I said experience. There is something called as significance level in hypothesis testing. You have to choose significance level. It depends upon you, the researcher, which improves with experience, with domain knowledge, with subject matter expertise. So, what significance level should be chosen? That depends upon the thorough understanding of hypothesis testing. That depends upon the subject matter expertise that you have in your domain. Okay, this does not come on day one. It comes with experience. So please understand that statistics gives you rule, but experience also matters in hypothesis testing in statistics. So now let's understand what hypothesis testing is. Actually, there are 7 steps in hypothesis testing. There are 7 steps, 7 rules have to be followed, 7 steps have to be followed. But for this discussion, I have simplified them into 5 intuitive steps. The first is you have a belief, okay, your belief. You want to test it. Going forward, whatever your belief would be, we'll call it as alternative hypothesis. What alternative hypothesis? We'll start calling it as alternative hypothesis. Your belief, alternative hypothesis, or H1. Why it is called as alternative? Because you're challenging the default belief of the world. That default belief is called as null hypothesis. So your belief is alternative hypothesis. You're challenging the default belief of the world. That default belief is called as null hypothesis. Suppose you believed or you start believing Earth is flat. That is your belief. That is alternative hypothesis. You're challenging the world's belief that Earth is round. That is null hypothesis. That is default belief, default assumption of the world. Null hypothesis. Alternative hypothesis, your belief. You're challenging the default belief. This step is called as defining your belief or defining your hypothesis. This is important because most of the time students fail in stating what is null and what is alternative. So very important step. Once you define the hypothesis, the next is to define the distribution. Which distribution? The distribution that you discussed in the statistics, the normal distribution, the t distribution, the f distribution, the chi-square distribution. So the discussion would be which distribution to choose. Normal distribution, t distribution, f distribution, chi-square distribution, Poisson distribution, which distribution to choose for testing. And actually the distribution here, the distribution is actually not the sample distribution, not the population distribution. It is sampling distribution. The distribution of sampling distribution. What is sampling distribution? We discussed it in normal distribution. If you haven't watched the session of normal distribution, go and watch the session of normal distribution. Sampling distribution is the distribution of the mean of the sample. And that is different from population distribution and sample distribution. So you have to choose what is your sampling distribution, or if you have forgotten that what is sampling distribution, then simply you have to choose a distribution. We'll discuss about this step in detail. So you have to choose your distribution, whether you go for normal, whether you go for t, whether you go for f, whether you go for chi-square distribution. That's it. Then based on the distribution, you calculate a test statistics. This step 3 is dependent upon step 2. If the distribution is normal, then you will calculate the test statistics and you will call it as Z statistics. If the distribution is T statistics. If the distribution is chi-square statistics. If the distribution is F statistics. Understood? This test statistics is actually a formula. What is test statistics? It is coming out of the distribution, but there is a formula. And you have to master those formulas. For Z distribution, there is a formula. For T distribution, there is a formula. For chi-square, there is a formula. For F distribution, there is a formula. There is a formula. So this one is formula based. You have to remember those formulas. What about test critical? What is step 4? Step 4 is calculate your test critical with the help of distribution. Please read step 4. Calculate your test critical with the help of distribution that you have chosen in step 2 and significance level. So you have to define your test critical value. Now for the test critical value, please understand, for the test critical value, you only have to read the table. What? Read the table. Which table? Z table for normal distribution, T table for T distribution, F table for F distribution, chi-square table for chi-square distribution. We discussed thoroughly in our series of lecture of statistics these table, how to read these table. So you have to start reading these table. This would be given in examination, and in the examination, they will provide significance level, which we also discussed is the area and the tail, but we'll rediscuss the significance level from the perspective of hypothesis testing. So with the help of Z table, T table, or any distribution table and significance level, You will calculate a test critical value. See, two values you are calculating. Test statistics with the help of formula, test critical value with the help of table. That is step 3 and 4. That's it. And 3 and 4 is dependent upon step 2, because if the distribution is normal, you will use Z statistics and Z table. That's it. With Z statistics, that is the formula, you will calculate a number. Say the number is 2. Z statistics number is 2, which you will call as test statistics. And you will calculate a number from the table. And you will compare those numbers in step 5. So what is step 5? See step 5. What is step 5? In step 5, I'm saying compare T critical and T statistics, as in test statistics and test critical values, and decide something. What to decide? Whether to reject null hypothesis or fail to reject null hypothesis. Actually, I have written here reject or accept null hypothesis. So you'll compare the number coming out of the formula and coming out of the table. If the test statistics is greater than the critical value, you will reject the null hypothesis. If this number is less than the test critical value, the test statistics number is less than the test critical value, you will fail to reject a null hypothesis. It depends upon what is the scenario. It is not always that this is greater than, less than, equal to, then you will always reject the null hypothesis. You have to define that decision rule after comparing these two values. So you will compare the test statistics and test critical value and say whether you rejected null value or you accepted the null value. You cannot say accept in hypothesis testing. For this discussion, that's fair, but in examination, you can never say accepted. You cannot use the word accepted. You cannot use the word accepted in hypothesis testing. You say reject null hypothesis or fail to reject null hypothesis. If you say reject null hypothesis, it means your belief is correct. The data is supporting your belief, your alternate hypothesis. If you say fail to reject null hypothesis, the data is not supporting your belief. Understand? That is the rationale of the decision that you made. Perfect. So these steps are the steps that you have to understand in hypothesis testing. These are critical steps. These are important steps for examination. So what we'll do in the next session, we'll try to master these steps. Step 1, 2, 3, 4, 5. What are these steps? We'll first try to define our hypothesis correctly. What is null? What is alternative? Then we'll choose appropriate distribution, whether to choose normal, whether to choose t distribution, whether to choose chi-square distribution, whether to choose f distribution. For mean, we may choose normal distribution or t distribution. We discussed about it. For variance, we'll choose chi-square distribution. For the comparison between the two variants of two different entity, we'll use f distribution. We discussed it in the series of lectures on statistics. So please refer to those lectures. Once we have chosen the distribution, we'll master the step to calculate the test statistics, as in Z statistics, T statistics, chi-square statistics, F statistics, and that are formulas. So we'll try to remember those formulas. Then how to read the table and define and determine the critical value. And the last is how to decide whether to reject null hypothesis or fail to reject null hypothesis. That is what we are going to master in this series of lecture on hypothesis testing. With that, I'll pause here. Thank you. Have a nice day.